Hello everybody, Mr. Tiller here. In this assignment we're looking at how scientists use data, the thing that's being observed or measured directly, and all their prior knowledge to draw inferences. Inferences are just conclusions based on the two things previously mentioned, the data, the thing being observed, and all the prior knowledge and experiences that one brings to every single situation in their lives. We're going to read a little paragraph. And while we read the paragraph, see if you can pick out examples of data and inferences, and then think about what prior knowledge and beliefs the scientists had to have in order to draw the conclusions that they did. I'm going to grab a highlighter here, and we'll look at just a couple of sentences. At Dinosaur National Monument, a museum has been built around a cliff face where a single layer of stone, some 4 meters thick, has yielded 14 different species of dinosaur. So in that particular example, where is the data? Well, if you can imagine standing in front of a cliff face and looking at that cliff face and determining how many layers of stone are present based on the different types of rock, and then pulling out your meter stick and measuring each individual layer. In this particular case, the thing being observed, or the data, is one single layer of stone. This layer of stone is 4 meters thick. Last part of that sentence has yielded 14 different species of dinosaurs. This is a little trickier. You do see the 14 different species of dinosaurs, and your initial reaction may be to call that data. But if you stop and kind of think for a second here, if you were standing facing that cliff face again, what would you actually see? What would be the thing that you'd be observing? Something that could be perhaps measured? Would it be 14 different species of dinosaurs? Or would it actually be just a big collection of dinosaur bones? And so the bones are actually the data. An archaeologist then would come along, observe those bones, remove them from the stone, and start to assemble them into various species of dinosaurs. That would require many conclusions, many inferences, determining which bones belong not only to each individual species of dinosaur, but which part of the dinosaur is represented by each bone. That individual would have to have extensive prior knowledge on the anatomy of dinosaurs in order to draw those conclusions. Continuing on, some were no bigger than a chicken. Others were the biggest land-living creatures the world has ever seen. 30 complete skeletons have been taken away, but bones of many more remain. The rock, which now forms the cliff face, was once a sand bank in the middle of a river. Let's take a look at that sentence for a second. The rock, which now forms the cliff face, was once a sand bank in the middle of a river. So what is the data? If you were standing again next to that cliff face, what would you actually observe? What would you see? What you would see is a cliff face. You could then go up to that cliff face and determine what type of rock is represented by that cliff face. In this case, it appears to be a sandstone. As soon as you saw the sandstone, as a scientist, prior knowledge would start to be activated, and you might start to remember certain instances from your life. For example, if you grew up near the Wisconsin River, you would have canoed on that river many times. You would have noticed in the middle of the river many sandbanks. You then would have, perhaps, your brain would have gone to that river upon observing this sandstone cliff face. You would have remembered back to those sandbanks. You could have then imagined those sandbanks over the course of millions of years being covered by sediment. That sediment turning the sand banks into sandstone. And there's your conclusion that the rock face was once a sandbank in the middle of a river. Now, why is it important to consider the prior knowledge and beliefs in the data when we look at conclusions that scientists draw? Well, if you have a different set of prior knowledge and beliefs, you can critique or make a different argument based on the exact same observation or data. So let's say, for instance, you grew up not near a river, but in the Sahara Desert, and your experience with sand was not sand banks in rivers, but in fact sand dunes in the middle of deserts. You could observe the exact same data, which is just sandstone, a sandstone cliff face, and from that data, and based on your own experiences, you might conclude that the rock which now forms the cliff face was once a sand dune in the middle of a desert. Now, just based on a different set of experiences, you can start to debate and critique the model of the first scientist. Gigantic rotten carcasses of dinosaurs floated down, beached on the sandbank, and were dismembered there, partly by putrefaction and partly by smaller dinosaurs that came to feast on carrion. All the long bones, such as those from the limbs and sections of the backbone, lie pointed in roughly the same direction, and from them we can deduce which way the river ran. So in that particular sentence, there's an obvious conclusion being made. The scientist is concluding based on the data, which is the observation that the bones lie roughly in the same direction. The scientist is concluding from that data what direction the river ran. And the prior experience then that this particular individual must have had involved an observation on a river, where perhaps something as simple as canoeing down a river as a child. You start grabbing twigs and sticks from trees that are leaning over the river, and you throw those in the river, and after doing this many times, you observe that those sticks always end up lying in the same direction, the direction the current pushes them. So that simple experience, combined with this observation of the bones laying in the same direction, leads this individual to draw the conclusion or make the inference regarding the direction this ancient river ran. I think we can stop there. The reason we're looking at this is because what we want to be able to do is critique various models. And one of the ways you can critique these models is if you bring to the table a different set of experiences, which allows you to interpret data or an observation in a slightly different way. So understanding where conclusions come from is an important part of this process.